Okay, so we're asked to rewrite the following expression in terms of exponentials and to simplify it as much as possible. And we're given this pretty long, kind of intimidating looking expression. But if we take a moment to examine it, we notice it's just two natural logarithms added together, and each of them isn't too different. One is taking hyperbolic cosine, adding it to hyperbolic sine. One is taking the hyperbolic cosine and subtracting from it a hyperbolic sine. And the arguments in each of these hyperbolic functions is exactly the same. So first what we're going to do is rewrite it in terms of exponentials. And to do that, we need to recall that hyperbolic cosine of u is equal to e to the u plus e to the negative u divided by 2, while hyperbolic sine of u is equal to e to the u minus e to the negative u divided by 2. And in this instance, our u is going to be equal to 3x because that's the argument in each of these hyperbolic functions. So to begin rewriting this, we'll get 2 times the natural log, I'll use a bracket, of 5 times e to the power of 3x plus e to the power of negative 3x divided by 2 plus 5, and this is a hyperbolic cosine, so this will be 5 times e to the power of 3x minus e to the power of negative 3x divided by 2. Let's add this to the other side, or not the other side, but to the other natural log function. We get 2 times the natural log of 5 times e to the power of 3x plus e to the power of negative 3x divided by 2 minus, because remember that's the only difference between these two sides, is one's adding, one's subtracting. So we're going to subtract here 5 times e to the power of 3x minus e to the power of negative 3x divided by 2. From here, what we'll do is distribute the 5 across. We'll distribute the 5 across in both of these natural logs, and because the denominator is 2 in all of these, we're just going to add it all together. So what we'll get is 2 times the natural log of 5 times e to the 3x plus 5 times e to the negative 3x plus 5 times e to the 3x minus 5 times e to the power of negative 3x, all divided by 2, plus 2 times the natural log of 5 times e to the power of 3x plus 5 times e to the power of negative 3x minus 5 times e to the power of 3x plus 5 times e to the power of negative 3x. I got that addition symbol because I was multiplying the negative 5 times the negative e will result in a positive 5e. That's all divided by 2. And we can notice that we have a positive 5e to the power of negative 3x and a negative 5e to the power of negative 3x. So those are going to combine together and equal 0. In other words, they will cancel out. While on this side, we have a negative 5e to the power of 3x and a positive 5e to the power of 3x. So on this side, it is the positive powers of 3x that cancel. So this will simplify to 2 times the natural log of 10 times e to the power of 3x divided by 2 plus 2 times the natural log of 10 times e to the power of negative 3x divided by 2. And we can simplify these by dividing that 2 to 2 times the natural log of 5 times e to the 3x plus 2 times the natural log of 5 times e to the negative 3x. Okay. From this, so we've used our basic algebra to simplify it to this point, and now we can recall that using the properties of logarithms, if we have, let's say, a logarithm of x plus logarithm of, I don't know, v, that is equal to logarithm of x times v. And so doing that, we can get, let me factor out the 2. It'll be 2 times the natural log of 5 times e to the 3x times 5 times e to the negative 3x. And this will equal 2 times the natural log, 2 times the natural log of 5 squared, and these will cancel, because remember, if we're multiplying two products with exponents, the exponents add, and 3x plus negative 3x is 0. Anything to the power of 0 is 1, except for 0. So really what we're getting is 5 squared times 1, which is equal 2 times the natural log of 5 squared. And then remember also, using the properties of logarithms, we can bring this out, the exponent out. And so that will equal 4 times the natural log of 5. That is the final solution.